All right, so for problem number 27, it says a square field measures 10 by 10 meters. I'm just going to sketch that out real quick because for me personally, it helps to have the image. So pretend that's a perfectly drawn square. And that this is 10 meters by 10 meters, okay? It says 10 students mark off a randomly selected region of the field. The region is square and has lengths of 1 meter, and no two regions overlap. The students count the earthworms contained in the soil to the depths of 5 centimeters beneath the ground surface in each region. So it sounds like they like take it and they like group it, like this, and then whatever the groupings are, and I don't know the exact number, but whatever the groupings are within that region, they count to see how many earthworms they have. Does that make sense? And then here are the results from that. So they have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 regions. Okay. Actually, when they list it like that, it probably looks more like this. They probably actually have like 10. They probably have like 10 columns like this. 1 foot. Oops, dang it. But you guys, well, let me just draw it in. You guys get the gist of it, right? They probably have like 10 long columns like this. 1, 2. I'm not going to be able to draw all 10 because it's. Anyways, you understand what I'm saying, right? Maybe the picture doesn't help if you're using Mr. Adams' tablet. So anyways, those regions, this is how many earthworms they find, okay? And none of them overlap. So it says, which of the following is a reasonable approximation for the number of earthworms to the depth of 5 centimeters beneath the ground surface in the field? Okay, now it may not have contained the whole, in other words, they might have just had 10 little sample spaces. It may not have taken up the whole field, and they're trying to figure out how many there are. Well, it's one region, right? So one thing that we could do, first of all, if it's 10 by 10 meters, that means this whole thing is 100 square meters, right? 100 meters squared. And then it says each region was a square that has a side length of 1 meter. So each little one of these samples was 1 by 1 meter, which is 1 meter squared. And they had 10 samples, right? Well, the 10 samples would be 10 times 1 meter squared, right? Or 10 meters squared. So the sample size, here's the trick to this, the sample size goes over the total size. And that's how we determine kind of the scale or proportion. So you would say 10 over 100, right? Or you could look at it and say that the students actually, if you do the 10, I'm going to rewrite this a different way. Now that I think about it, maybe we should just focus on just the one sample size of 1 meter squared. So each sample that they have is 1/100th. One 1/100th of what they have. Okay. So then what do? Well, the smaller region, so the counts range from 107, I think, is the smallest number, to 176 is the largest number. So we'll start there. So if it's 1/100th, we could take those numbers and multiply them by 10. In other words, we could say 107 times 100. I said multiply by 10, but if it's 1/100th, that would give us a lower boundary of 10,700. That would be like the minimum it could be. And then the maximum boundary would be 176 times 100, which would be 17,600. So this could be like a minimum This would be a lower boundary. This could be like a maximum, the most that you would find based on the sample sizes. So which one do you think works? Yeah, C would be a reasonable approximation. Now you could take the average of those two, but that's a reasonable one. That's a lot of earthworms in that field. Holy moly, 15,000.
And 10 by 10.
10 meters by 10 meters.
How far down are they digging?
Yeah. Oh, well, I don't know where my meter stick is, but yeah. Well, it's only 5 centimeters.
Oh.
So 5 centimeters is like that. Well, here's 5 centimeters right here. 5 centimeters is like that.
That's so many worms.
Yeah. Well, it's 10 meters by 10 meters. So, anyways, can we move forward? I will leave that up there for a second so you guys can finish